So hello everyone, in this audio class we will discuss the 20 most important question and their answers from the chapter landforms and their evolution. These questions will be very much important for your upcoming KBS and NBS PGT geography. So let's get started with the question number 1. What is a landform and why can no landform be studied in isolation from geomorphic processes? So a landform is a natural physical feature of the earth's surface such as valleys, mountain, plateau, delta or dune. Every landform is the result of the action of geomorphic processes and agents. Therefore, no landform can be studied separately because its origin, evolution, shape, size and materials are directly controlled by the geomorphic processes like weathering, erosion, transportation and deposition. For example, a delta cannot exist without river deposition and a valley cannot form without river erosion. So the next question is, how do geomorphic agents transform a landscape over a long period of geological time? So geomorphic agents such as running water, glaciers, wind, waves and groundwater continuously erode, transport and deposit materials. These processes gradually modify the earth's surface and create different landforms. Over geological time, mountains may be reduced to hills, valleys may widen and new depositional plains may develop. For example, the Himalayas are gradually being eroded by rivers while the Ganga plain is being built by deposited sediments. Next question, why does running water produce both erosional and depositional landforms simultaneously? So running water erodes material from higher areas, transports it and deposits it where its velocity decreases. Therefore, erosion, transportation and deposition are parts of the same fluvial process. The upper course is dominated by erosion whereas the lower course is dominated by deposition. For example, a river may form potholes in its upper course and a delta at its mouth. Next question, how does a river valley evolve from the youthful stage to the old stage of the river development? So in the youthful stage, vertical erosion dominates and V-shaped valleys, rapids, waterfalls are common. In the mature state, lateral erosion increases, valleys widen and meanders develop. In the old stage, deposition becomes dominant, floodplains, natural levees and oxbow lakes are formed. For example, the upper Ganga represents youthful characteristics whereas the lower Ganga shows mature and old age characteristics. Next question, why are waterfalls and rapids considered indicators of the youthful stage of a river? So waterfalls and rapids occur where the river has a steep gradient and high erosional energy. Such conditions are typical of the youthful stage where vertical erosion is dominant. For example, Jog Falls and numerous Himalayan waterfalls indicate youthful river stages. Next question, how are V-shaped valleys formed and what do they indicate about the erosional power of a river? So V-shaped valleys are formed by intense vertical erosion by rivers. The river cuts downward faster than the valley sides can widen, producing a narrow valley with steep slopes. For example, many Himalayan valleys are V-shaped valleys. Next question, what are potholes and why are they regarded as evidence of vertical erosion? So potholes are circular depressions formed in river beds by abrasion. So pebbles and boulders rotate in the depression and deepen them further. They indicate strong vertical erosion by running water. For example, potholes are commonly found in rocky river channels. Next question, why are meanders generally associated with mature and old stages of river development? So in mature and old stage, the river gradient becomes gentle and lateral erosion becomes dominant. The river starts swinging from side to side, producing meanders. For example, the lower course of Ganga exhibits large meanders. Next question, what is the significance of incised meanders in reconstructing the geomorphic history of an area? So incised meanders are deeply cut meanders found in hard rock regions. They indicate that meanders developed on a gentle surface and were later entrenched due to uplift or renewed erosion. Thus, they provide evidence of past geomorphic conditions. For example, incised meanders are found in canyon regions. Next question, how do oxbow lakes develop and what do they reveal about the lateral erosion of rivers? So oxbow lakes form when a meander loop becomes so large that the river cuts through the neck and abandons the loop. The isolated loop becomes an oxbow lake. They indicate active lateral erosion and channel migration. For example, numerous oxbow lakes are found in the Ganga floodplain. Next question, why are floodplains considered the most important depositional landforms created by river? So floodplains are formed by repeated deposition of fine alluvium during floods. They are extensive, fertile and support dense human settlements and agriculture. For example, the Indo-Ganga plain is one of the largest floodplains in the world. Next question, differentiate between alluvial fans, natural levees, point bars and deltas in terms of their process of formation. So alluvial fans form at the top of hills where rivers suddenly lose velocity and deposit coarse materials. Natural levees form along the river banks during floods due to deposition of coarse sediments. Point bars form on the convex sides of meander due to lateral deposition. Deltas form at the river mouth where rivers enter standing water bodies and deposit fine sediments. For example, Godavari Delta is a classic example of a delta. Next question, why are deltas formed at the mouth of some rivers while estuaries are formed in others? So deltas formed where sediment deposition exceeds marine erosion. Estuaries form where strong tidal action removes sediments faster than they can accumulate. For example, Godavari forms a delta whereas Narmada forms an estuary. Next question, what are river terraces and how do they provide evidence of climatic change or tectonic uplift? So river terraces are remnant of former floodplains left at higher levels due to renewed river erosion. They indicate changes in the climate, river discharge, tectonic uplift or sea level. So terraces are common in hilly river valleys. So next question, why is groundwater more effective in shaping limestone regions than regions composed of other rocks? So limestone contains calcium carbonate which is easily dissolved by carbonated water. Therefore, groundwater can create extensive underground drainage systems and karst features. For example, limestone caves are common in karst regions. Next question, how do sinkholes, caves, stalactites, stalagmites and pillars demonstrate the combined action of solution and deposition? So groundwater dissolves limestone to create sinkholes and caves. Later, dissolved calcium carbonate is deposited inside caves as stalactites, stalagmites and pillars. For example, many limestone caves show these depositional features. Next question, why climatic and geological conditions are necessary for the development of karst topography? So karst topography develops where dense and well jointed limestone occurs near the surface, rainfall is moderate to heavy, and groundwater circulation is effective. For example, karst landscapes are common in limestone regions. Next question, how do glaciers act as a powerful agents of erosion, and why are U-shaped valleys considered characteristic glacial landforms? So glaciers erode by abrasion and plucking. Their enormous weight enables them to deepen and widen valleys. As a result, former V-shaped river valleys are transformed into broad U-shaped valleys. For example, many Himalayan and alpine valleys are U-shaped. Next question, explain the evolutionary relationship among sarks, turn lakes, horns and serrated ridges. So a sark is the birthplace of a glacier. After the glacier melts, a turn lake occupies the sark basin. Headward erosion of multiple sark creates sharp peak called horns and narrow ridges called serrated ridges, that is called arete. So for example, Matterhorn in Alps is a classic horn. Next question, and this is the last question for today. Compare the erosional and depositional landforms produced by rivers, glaciers, wind and coastal waves. So river erosional, that is V-shaped valleys, potholes, waterfalls. Depositional, floodplains, levees, deltas. Glaciers erosional, sarks, U-shaped valleys, horns. Depositional, moraines, escarps, outwash plains. Wind erosional, Yardang, Jugen, deflation hollows, and deposition, dunes, loess, ripples. Coastal waves erosional, cliffs, sea caves, sea stacks, and depositional, beaches, speeds, bars. So thus each geomorphic agent produces a unique landscape according to its energy, climate and mode of action. So thanks for listening. Keep listening for further audio classes. Thank you.